And that's the answer to your question, is in this case, so I'm going to get C prime of t, which is the marginal cost of investing at date t, has to be equal to integral from t to infinity, e to the minus r tau minus t, v prime of tau minus delta c prime of tau. Okay, d tau. This, of course, is my marginal cost. So the marginal cost of producing a unit of capital, marginal cost, equals a present discounted value at R. And what is this? Anybody know what we call that? What is V prime minus delta C? C prime, sorry. What is that? Anybody know what that's called? It's called the net return on capital. Right? That is the net return on capital, because it's how much that unit of capital returned today minus how much I had to pay to maintain it, because this is the maintenance cost, right? This is the cost of paying the depreciation on that capital. So you could say the marginal cost of investment has to be equal to the present discounted value of the net return on capital. So that's one way to look at investment. That's different than what we did, right? We did it a different way, but this is an equally valid approach. Now, the way we did it, we actually considered a slightly different perturbation than this one here. We considered a perturbation where you invested more in K today, increased K dot, but then I held investment fixed in the future, so that stock then depreciated at rate delta. That would give us almost the same formula, but because the stock is going to depreciate in the future, I got to discount at R plus delta. So I would get marginal cost equals C prime of t equals the integral from t to infinity e to the minus R plus delta tau minus t. Then I'm going to get v prime of tau d tau, because there's no more. Remember, in that experiment, I'm holding investment fixed, so this doesn't change in the future. So I don't have to pay the cost of maintaining that extra unit of capital, but the loss from doing that is that capital is going to depreciate away now. Everybody understands? It's just a different perturbation. The first perturbation I did was you invest a little more today, and then you maintain that higher capital stock forever. That corresponds to saying the marginal cost of investment has to be the present value discounted at the market rate of interest of the net return on capital, because you have to pay the cost of maintaining your higher capital stock. Another way to think about the investment problem is that the marginal cost of capital, the marginal cost of investment, has to be equal to the present value discounted at R plus delta of the gross return on capital. This is a bigger number, right? Because you're not paying the depreciation. It's a bigger return, but you're discounting at a higher rate. And they're equally valid ways to look at the world, right? Because we could consider any perturbation we want, right? We could have increased the capital, kept it around for 37 and a half years, and then disinvested then. That would give you a different formula, right? Any formula you want is fine. These are just two very convenient formulas to think about. One is invest in capital, keep it forever. The other is invest in capital, keep it as long as it lasts. The one formula we did in class before, with present value formula we wrote down, was invest and let it depreciate, right? Either one is equally good. The reason I bring them both up is because people make a lot of mistakes by confusing which formula they're using. They think about the gross return on capital, they think about the net return on capital, and it's either one is a perfectly valid approach to the world, just like real and nominal are equally valid approaches to thinking about the world. But if you're using real, you got to stick with real. If you're using nominal, you got to stick with nominal. Same is true with gross and net returns. If you're going to talk about gross returns, then you got to remember I'm using gross returns here. All right? So if I got gross returns on capital, I got to be discounting them at int R and delta. On the other hand, my net returns, I can discount only at R. Right? You start mixing them together, you start getting confused. Okay? So be careful with that. But these are two equally valid approaches. And if we write down this problem, you can see this is our equilibrium condition, right? Because this is marginal cost of investment equal to the present discounted value of the net return, or equivalently, this is really the formula we use, the height of the supply curve equal to the present value of future rents.